Hey guys, it's Dr. Smith again. I wanted to give a short video since we missed class the other day on adjusted R squared. Up to this point, we've talked a lot about R squared, or we spent some time discussing what it meant and how to use it and what it's telling us. So just looking here at the data that we have, right? We have R squared in this regression. This is a regression where the dependent variable is wage and the independent variables are education, experience, and tenure. In this case, we see that R squared is 0.1458. And what that tells us is that 14.58% of the variation in wage is explained by the variables in our model, or the variation in the variables in our model. And so that's what R squared tells us. And so up to this point, we haven't talked about what adjusted R squared is. And so I want to talk for a minute about what that is actually telling us. So one thing we have R squared, some people get really hung up on R squared, like, oh, I want to make R squared as big as I possibly could. A big R squared is a good thing, but you can make R squared go up without really doing anything, without adding any explanatory power to the model. And let me give you an example for that. So what this is saying is, there's, hourly wage is moving around, right? It's changing between people. And here we have three variables that are explaining, I think it's actually monthly wage, right? Explaining the person's monthly wage. And those are education, experience, and tenure. And those three variables are explaining, about 14.5%. Now, it's possible we can add more variables, and anytime you add a variable to this regression, R squared will go up. It might go up by just a little bit, or it might go up by a whole heck of a lot. But it's going to go up, because think about it this way, you can never explain less by adding more variables. Does that make sense? You're never going to do worse than you're doing right now. And so since you can never explain less than you are already explaining, R squared will never go down when you add a variable. It will only go up. Go up a little bit, go up a lot, but it's going to go up. So let me show you that. So let's go over here to our wage data. I'm going to rerun that regression. Let's come here to data analysis. I still got our Y variable in there, but let's add our age variable, okay? And so what we're going to do is we'll come here, we'll select education, experience, tenure, and age. And let's see what happens. We'll go ahead and select that all the way down using Shift Control down. And then we'll run that regression and let's see what happens. Notice our R squared went up to 15%. So before it was 14.5%. Now it's up to 15%. So that's actually, that's an increase, right? So now we're explaining 15% of the variation in monthly pay. So that's what those R squared means. It makes sense, right? We added a variable, so now we're explaining more than we used to. Now the question is that variable really helping or not, right? And because we said, anytime I add a variable, whether it's a great variable or a completely stupid variable, it's going to increase the explanation. And let me show you that, right? I'm going to come here and I'm just going to create a new variable. I'm going to come up here to the top. And it's going to be completely random. Absolutely completely random. We'll come in here and we're just going to call this random, right? It is literally, we're going to come here and we're going to say random. This just gives you a random number. I'm going to multiply that times 1,000. Just so that it's just some ridiculously, completely random number that we have. Copy that all the way down. Boom, random numbers. Okay? Now, watch. We're going to include that random number into our regression. And R squared is going to go up. Okay? It is. It's going to go up. Because, again, we can't do worse than we're already doing. So, let's come here and let's go to data analysis, regression. We'll select the variables we care about, including that new random variable. What did I just do? Let's come back over here. Clicked on the wrong thing. Shift Control down, not Shift Control left. Shift Control down, and we say OK. Okay, so we've run our regression, and here we go. We come down here and look, and r squared, did it go up at all? Let's see. I'll go flip back and forth. Oh, just a little bit. R squared went up a little bit. It went from 0.1501 to 0.1502. So r squared went up. We're explaining more than what we used to. You know, it's a miracle. No, not really. It's just random chance, right? This random number just happens to be explaining just a little bit of the variation in hourly wage. I mean, it is, but it shouldn't be, but it is by chance. So r squared went up, and r squared will always go up anytime you add a variable. In this case, it went up a little bit because in reality, this variable doesn't matter. In fact, we come down here and look at the p-value. The p-value is 80%. This is not significant at any level of significance that we care about. I mean, not even close to being significant, which makes sense, right? Because we just purely randomly generated it. It doesn't have any explanatory value. It doesn't affect hourly wage. I mean, we know it doesn't because I just made it up on the spot. But it, for some reason, in this data set, is slightly increasing our explanatory power of the model. But it shouldn't, right? And so let's look at how adjusted r squared has changed over time. So here's the initial data that we had where we ran our independent variables, or just education, experience, and tenure. Then we included age. So let's look, right? Going from here, we had an r squared of 1.458. That increased to basically 15%. So r squared went up. Notice, so does adjusted r squared. Adjusted r squared goes from 0.1431 up to 0.146. So adjusted r squared also increased. Now, let's go from this model and let's include in our random variable. Again, if you look at just r squared increases. It barely increases, but it increases. But if you look at adjusted r squared goes from 0.146 to 0.145. Adjusted r squared actually goes down. So it is possible for adjusted r squared to fall and not increase when you add in a variable. And you might be going, Dr. Smith, how is that possible? It's because the formula for adjusted r squared basically adds on a penalty. Okay, that's the way to think about it. Is basically every variable that you include in the model, your r squared gets penalized, right? It hurts it. It's going to knock it down. And so what you want, and so for adjusted r squared to go up, the extra amount of explanatory power that it gives has to be bigger than that penalty, right? The penalty is taking away points, and the extra explanatory power is adding points. So if it doesn't add as many points as it takes away in the penalty, adjusted r squared is going to fall. Okay? And so in this case, because that variable did not add much explanatory power at all, it took more points away than it gave, and so adjusted r squared falls. Okay, and so one thing that you can kind of look at this, you can use adjusted r squared to to compare models sometimes, right? So we can say, okay, well, if we just added in a variable, how did that increase adjusted r squared? Well, if it made it go down, then that might tell you, oh, well, maybe that variable that I'm adding isn't one that really is helping me whatsoever. And there's a couple ways to see that. One, the p-value is very low, but you could also use that adjusted r squared to kind of tell you, well, I just added this variable, adjusted r squared went down, so it's probably not that useful. It's not giving me much explanatory power, and so that's something to keep in mind. So what's the formula for adjusted r squared? Well, it's based on r squared. So what we're going to do is let me just write out that formula here. So there's a couple different ways of writing adjusted r squared. Sometimes I'll just write that out, adjusted r squared. Sometimes you'll see it as r squared, and I apologize my paint here, but adjusted r squared, I'll have a bar over it like this. That's also the notation for adjusted r squared. But the formula for this is actually pretty easy. It's adjusted r squared is just 1 minus 1 minus r squared. Well, that's a janky r. Let's come here and fix that. R squared. Okay, so right now this looks really stupid. Why would I do 1 minus r squared? But this 1 minus r squared quantity here is going to be multiplied by n minus 1 over n minus k minus 1. And that's the formula for adjusted r squared. So notice what happens. When k gets bigger, we add a variable to the model. This denominator gets larger. Okay? And that denominator getting larger is what I was talking about a minute ago when I was saying it adds in a penalty for adding in that variable. Because that denominator getting larger makes basically the r squared smaller. And that's what we end up with for adjusted r squared. So that penalty basically lowers from r squared. And then so if r squared doesn't go up by as much as the penalty lowered it, that's when adjusted r squared will fall. So what I really want you to get out of this is two things. One, if I give you r squared, right, and I give you n and k, then could you calculate r squared? Sure you could. You just plug into the dadgum formula. It's not hard. I also want you to know, if I tell you, so you just added a variable to a model, and r squared went up, it always will, but adjusted r squared went down, what does that tell you? And what you really want to get out from that is, well, that probably means that, that variable that we added doesn't really add any explanatory power. And so we might just want to leave it out of our model. So it's one way of kind of looking at, does this need to go in the model? Does it not need to go in the model? So, because in real life, you don't have a professor like me telling you this is the model to run. You have to kind of think about it. And so this is one of those ways to tell you, should I include something, should I not? And so anyway, that's adjusted r squared. This will be on the in-class problems that we work on Monday. And that's it. Well, thanks, guys, for watching. If you have any questions, we'll go over all this again on Monday, right before we work some in-class problems, just as a refresher. See you guys then.